Let's look into iCloud document storage. So in principle, you have a folder in the cloud and you have more or less an exact replica of that folder on your local device. You can upload and access the folder on your device, and in the background the operating system will take care of synchronizing that folder with whatever lives in the cloud. And since every device does that, the data on every device should be in sync. That's the theory, and in practice we're going to find out how that works. So on the good side, on the plus side here, you're only limited to a user's iCloud space. So if a user has 5 GB of free space by default, you could technically use it all. To access that folder on your local device, we need the URL to the so-called ubiquitous container. Think of that as the copy of the cloud folder on the local device. That's called the ubiquitous container. I like to call that my iCloud folder because that makes much more sense to me. But in Apple speak, it's the ubiquitous container. This is made up of your team ID separated by a dot from the container ID. The container ID by default is something like the reverse dot notation of your app. Often the container of one app is just the bundle identifier. It doesn't have to be, but by default it is. So imagine your bundle ID would be com.domain.yourapp, then your container, the URL to that container would be made up of this team ID xyz123.com.domain.yourapp. If you want to share data between apps, then you can use more than one container ID, but we're not going to cover that. In our case, we're going to assume that our bundle ID is the same as the container ID. And of course, I'm going to show you how to find your team ID because they made sure it's very well hidden. If anything changes in our iCloud folder, we would like our app to react to that. And by default, there's no easy way to do that. So we're going to use a metadata query to detect changes. As soon as that happens, the metadata query will send an Dns Metadata Query did update notification to us, to which we can react. The metadata query is a complex class, and it's not an iCloud class as such. We're just going to repurposing it and telling it, hey, look at a single folder, which is our ubiquitous container, and in case anything changes, let us know. There are other ways of doing it, but this is the simplest way. There's one big difference between Macs and iOS devices in that Macs are so-called greedy peers, and that means that if a change is detected in their ubiquitous container on the Mac, then they download that change immediately. So a new file comes in, they detect that, and they immediately download the content. On iOS devices, we need to download files specifically. Think of that as there's the file wrapper versus the file content. As soon as a change is detected, that change isn't downloaded on iOS devices. So we're only going to get that new wrapper, but we don't get the new content. We need to go ahead and download that manually. I suppose that's because iOS devices want to preserve energy and they want to preserve bandwidth, so only explicit downloads are going to happen. I know this sounds all really complex, which is why Apple have gone ahead and written a class that specifically deals with all these things, and that's called the UI document class. It's not an easy class to get your head around, but as soon as you get the hang of iCloud document storage, you may want to look into that. We're not going to cover that here because I find that when I got started with this topic, UI document adds a layer of complexity into this already very complex matter that just blows this all out of proportion. So we're not going to touch this here. I was thinking long and hard of how can we demonstrate this, and I came up with a plan, which is we're going to create a simple app with, let us pick an image from the camera roll, display it in a UI image view, and then upload it to iCloud. So we need to build a little bit of UI here, but it's not that complex. We're going to use a Uiimagepickercontroller and an image view in a single view application to do that. We're also going to build a method that will let us download and display that image as soon as we detect a change in our iCloud folder. Sounds good? Let's go ahead and do this in code. I'm going to create a brand new Xcode application here. I'm going to use a single view application. I'm going to call it Document Store. iPhone only. And I'll whack it on my desktop. Let's prepare our app for iCloud first. I've shown this to you in the first video, but I'm just going to repeat these steps rather quickly. I'm going to select my team here. Bundle identifier is unchangeable due to this gray thing here, so we head over to Info, and under here, Bundle identifier, we're going to take that variable out, and I'm going to use the same app ID and provisioning profile from the previous app. So that's just com.pingstonepictures.iCloud. There. Under capabilities, I will just flick the iCloud switch, use the key value store, and I'm going to make a note of this. So the Ubiquiti container is the same as my bundle ID right now. That's what I was saying earlier. If you had more, you'd have to add all the other Ubiquiti containers here that you want to use to share data between other apps. Let's build the UI first. Let's head over to the storyboard, in which we find a single lonely view controller. He's not going to be so lonely if we go over to editor and embed him in a navigation controller. We do this because then we get the navigation bar up here, and we can drag a single button into it, and that button identifier, I'm going to change that to camera. There, not so bad. Let's also find an image view. That's this guy here, UI image view. Drag it in and just make it fill that whole space. There's only one change I want to make to the image view. Under mode, I don't want scale to fill, I want aspect fit. So as soon as we add a picture there, it'll just not distort the aspect ratio, it'll just fill up the whole picture. Alright, let's hook this up to our view controller and head over to our assistant editor. And since the image view is already connected, I'm going to control drag from that into my view controller implementation file, just anywhere between interface and end will do, and I'm going to call it image view. Good. The other thing I want to connect is that camera button. I'm going to put that underneath my property. This is going to be an action, and I will say this is load image. Or let's say pick image rather. It doesn't really matter as long as it's an action. Cool. That's that. Let's go back into the standard controller and into that view controller implementation file. Let me fold all those methods so that we get a bit of zen here, and let's deal with that pick image method first. As I said, we're going to do this with a Uiimagepickercontroller. So in order for our class to react accordingly, it needs to conform to a couple of protocols. The first one, you've guessed it, is the Uiimagepickercontroller delegate, which can't exist without the Uinavigationcontroller delegate. It's just the way the class is made. You have to have both in order for there not to be any warnings. Under pick image, in fact, let's put a pragma mark here. We'll say select an image. And here's how we create an image picker controller. If you're not familiar with those, don't worry about it. It's a simple thing. It's sometimes code completion doesn't really work that well. We just need to set the delegate to self, because this class is going to be the class that will react. Create it, allocate, init it, set the delegate to self, and then just bring it up. That's all we need to do. So we'll say we are a UI view controller, so we can say self present view controller picker animated yes completion nil, because we have a delegate to react to that. That's all we do in the pick method here. Underneath here, we're going to implement a couple of delegate methods. So the first one is if we bring the image picker up, but we decide not to pick an image, then we're going to cancel. Image picker controller did cancel. That's that. And what we'll do here is we're going to be past the picker that was cancelled. So we'll say dismiss view controller animated yes completion nil. All right. The second delegate method that we're going to implement is what happens when we actually did select an image, which is this one. Image picker did finish picking media with info. Ah, I like it. Let's do that. First thing we're going to do is we're going to dismiss this guy, just like we did with the cancel method. But then we also like to take our image from the picker, and here's how we do that. We're going to be passed not only the picker, but we're also going to be passed this info dictionary here, and that will contain several types of images. There could be the original one, there could be the downscaled one, there could be an edited one, and so forth. We're going to grab ourselves a UI image, just going to call it image, from info, and there we go. If you start typing Uiimagepickercontroller, there's the edited image, crop rectangle. In fact, let's just go with the original image. Now that we have an image, let's add it to our image view. So self image view image equals image. That should be enough. Down here, we also need to save image in iCloud. We'll do that once we've tested our UI. So for now, I think I should be able to run this app, bring up the picker, and at least display the image. Let's try this. Okay, nothing much to see. Let's hit the button. Button brings up my photos. Since this is a simulator, I've just picked 2 randomly from the internet. I like Portal, so there we go. That works. Click on it again. Pick another picture. Okay, rudimentary UI works. Now let's make this work with iCloud. Our first order of business is going to be finding out a URL to our iCloud folder. I say because we could do this from any class, let's put this into our app delegate in the implementation file. Let me collapse all the methods here. And on the bottom here, sometimes when you use a core data app, then Xcode will have already put something along the lines of application documents directory, which is a similar method that allows you to access the current documents folder. We will follow suit here, and we're going to return an NS URL, and we're just going to call it application cloud folder. And not only that, we're going to take one parameter, and it becomes clear later why we do that. It's just going to be a string, and we're going to call it file name. So my idea is that we can call this method with the file name, and we get the file name with an appended iCloud folder URL returned. So return nil currently. So we suppress the warning. And of course this is a pointer. There. Let's set a couple of references first here, which is the team ID and container ID. I will show you in a minute how to find that. For now, we're just going to leave it as team ID here. The other thing we need is our bundle ID, so it's another string. We could go and hard code it like so. Or we could literally take our bundle ID. It depends really what you've chosen here. If the bundle ID and the container is the same, then you're more than welcome to use this. Otherwise, you could just go bundle identifier, like that. In our case, it'll be the same, so I'm going to leave it like this. We're going to concatenate these two into the container ID. String with format %at dot %at. And therefore we're passing the team ID and the bundle ID. And that makes our container ID. Next we'll grab the URL of our ubiquitous folder. So this is going to return an NS URL. I like to call it cloud root URL. This is a bit like the root directory to your application documents directory without the documents folder. So the documents folder I'm going to explain in a minute. We have the same here in iCloud document storage. You can use it, you don't have to. We're just going to grab the root URL for now. And we do that with the file manager. And it has one method, which is the URL for ubiquity container identifier. Good thing we have it. So we'll pass it the container ID, and it will return us a URL to our folder. This is the thing with the documents folder. You may have seen this on apps, that when you go and head over to settings, and in fact maybe I'll show you. Here's my real device. The simulator won't be able to show you this. If you head over to settings and you find the iCloud section here, and you're logged into an iCloud account, on the bottom here you find this section storage and backup. This is a bit convoluted here. You head over to manage storage and you find all your devices here, and then down here you find this documents and data. And the thing with that is, if you look at an app like iPhoto, which currently on my device has 585 kilobytes, if you go into that, you just see documents and data occupies that much space in iCloud. They have done it in a way that they're saving all the iCloud data in the cloud root folder, so it doesn't appear as individual items. If you go back, and I've written an app here, the bike tour diary, which has a lot more in iCloud, you can see that this has several elements, and this happens when you append documents to your cloud root folder. So if you create a subfolder called documents, then you're exposing every single element here. And when users hit edit, they are able to delete single documents here. So it makes a lot of sense for apps such as Keynote and Numbers, for example. You go in and these are all your individual Numbers documents, or likewise here in Keynote, 172 megabytes saved in Keynote. Those are all the Keynote presentations I currently have in my iCloud storage. So I could go ahead and delete them from here if I wanted to. I can also at the bottom delete everything that this app currently uses. This is a good thing to keep in mind, that if you save things in your iCloud Documents folder, they're accessible to users individually, whereas when you save it in the root folder, that is not going to be possible. Back to the code. In our case, I think it's a great idea if we just make that available. That's great for testing. If we're going to leave it in for a production app, up to us. Let's decide that later. So for now, all we need to do is pass documents to the end of that cloud root URL in order for that functionality to be available. Now all that remains is to append our file name, cloud documents, file name. That's what we've been passed in at the top here. And now we'll go and return all that. Right, so as soon as we call this method, we should get a URL with a file name back. Let's head back into our view controller implementation file. First thing we're going to do, under import, we're going to import our app delegate. So we can call that method. Here when the image picker returns, we want to save that file in iCloud. So first of all, we'll create a reference to our app delegate. And then we'll grab that URL from that method that we've just written. It doesn't actually come up. I do apologize, because back in our app delegate, it needs to be a public method. So copy that signature, put it into the header file, and add it on your properties. So now our view controller can actually call that method. Application cloud folder with our file name, which in this case is going to be the picture. Okay, we have a reference. Now how do we save our image? With Uimages and NS images it's a little bit bizarre, but we have to call a method that turns the image into data, and the data can be saved as a file. So if you're not dealing with images, you can probably just use a NS file manager method that copies one URL to the other. We're going to have to do this data tweak here. There's nothing to worry about. Imagine it's just a file. This is exactly what we're going to create. So first I'm going to create a data object. and this UI image PNG representation will just turn an image into data. In our case, it was just called image. And because the data object has a method that lets us save something as a file, we can just go and call that. Write to URL cloud image atomically, yes. And that's that. This will save our picked image in iCloud. It will also display it in the image picker. The next thing we need to do is basically the reverse of this, and we need to create a method that will populate our UI if there has been a change. A little void method will do the trick. We're going to call it the same as what we did in our previous example. We're just going to call it populate UI. And if we do the opposite of saving an image in iCloud, we're going to load it from iCloud. First thing, we need to grab a reference to our app delegate again. If you do this a lot, you can set this up as a property, of course. But it's just one line of code, and all we're doing is typecasting whatever comes out of UI application, shared application dot delegate as the app delegate, giving us the reference to that. I'll call it cloud image URL. This is what's going to come out of the picture. And just like before, this is going to be data, so I'm going to load this as a data object. Data with contents of URL, cloud image URL. And then I'm going to turn that data back into an image. Groovy. All that remains to be done is that we put that image into our image view. So notice that as soon as this method gets called, I'm trying to already load that image in. But as we said earlier, we need to make sure this actually gets downloaded. So before we just display it, I'm going to put a little if statement here that checks if the image actually exists. And if it does, let's go ahead and display it. If that's not the case, let's download it first. I'm going to put a log message as well so that every time this method is called, we can actually see what's happening. And we can do that with another file manager method. Start downloading ubiquitous item at URL. In our case, that was cloud image URL. We're so confident that we don't need to have an error object here. We don't really need to worry about the fact that this method gets called again and again. It will, because downloads happen in chunks. We'll see that in a second. There's one last thing we need to do, and that is we need to actually call this method as soon as we detect iCloud changes. For this, we need our good old friend, the Dns Metadata Query. It's nothing to be afraid of. It's just a bit of code. I'm going to paste this underneath the video so you have access to it as well. I'm going to declare a property up here, and I'll just call it query. And at the bottom here, I'm going to add a custom initializer for that. If we don't have a query, let's make one. We need to tell the query the search scope, which is just an array. You could tell it more than one scope. So a scope, think of that as where do you want that metadata query to be executed. Local documents folder, some other folder, remote folder, or in fact the iClouds folder. So in our case, it is the iClouds folder, and it's an enumeration that we can call here. And as metadata query ubiquitous document scope. This will specifically look in the documents folder. We're going to add that to search scopes, There we go, scopes. The next item on our list is that we need to give our metadata query a predicate. And a predicate, that's another weird little thing that sets up a search query specifically. And the string star. And then we're going to give our query the predicate. Don't worry too much about this code. I'm going to paste this underneath the video. This is our query. Now we need to set up an observer to kick off the query. Let's say we do this in view.load. Add observer is self. The selector is our populate UI it was. The name is the notification we'd like to observe, so in this case it's the Dns Metadata Query did update notification, and the object in this case is self query, because that is what's going to be sending that notification. That right now is all there's to it. Let's test this on the simulator and 2 real devices and we'll see if it all works. Do you know what? I've just noticed that there is something that we've totally forgotten, and that is our team ID. We can't run the app yet because we need our team ID. But it's no problem. We go over to developer.apple.com, just like where we were provisioning our provisioning profiles, and we head on to the iOS Dev Center. Just like before, we head over to Certificates, Identifiers, and Profiles. And once you're there, once you're in this screen, there is a little tab on the top right here, which is a drop-down that lets you view your account. This will show you all kinds of information about your current developer account. And underneath here in the developer account summary, you find your team ID. That's the one that you need. That's unique to you and your team. And we just need to quickly copy this and add it into Xcode. Remember, this was the method in our app delegate, the one that gives us the iCloud root folder. There we go, team ID here. So let me just replace that with that. This is going to be unique to every developer account. Right, now let's see what happens when we run this app. Let's run this app on the simulator, and I'm also going to run it on my iPod Touch, and I'm going to run it on my iPhone as well. And I'm just going to look at those devices and leave Xcode kind of in the background here. Right, let's start with the simulator. Upload an image here, maybe my Portal image again. I like Portal. Just discovered it on Steam again yesterday, very exciting. So okay, this should now, after a bit of waiting for it, populate this same image onto both of these other devices, if the simulator works properly. What we can't do looking at these 2 other devices is have a look at the debug output here, because under these iCloud headings here, if you head over to the debug navigator, you can select iCloud and then you can see the data that's being uploaded or downloaded. It looks like right now the simulator doesn't actually upload this image at all. So let's try my iPhone and pick something here. Maybe a mosaic table. Oh, and there we can see the green means things are being uploaded, and blue means data is being downloaded. So if we look on the iPod Touch or the simulator, everyone's uploading data madly. That's very good. Oh, there we go. So it looks like the iPod Touch now has this image. The iPhone, it's an original large camera image, is still uploading this image. So the smaller the images, the quicker this is going to populate, and the larger the images, obviously the longer it's going to take. iCloud does all this in the background, and you can see here the chunks are getting smaller. So in a moment we should see this image pop up here, at least on the iPod Touch. I'm never quite sure with the simulator if it's going to reliably work or not. There we go, looks like that image has populated. to the iPod, I doubt the simulator is going to get it. Like we tried in the previous exercise, the simulator looks like it can send data, but it's not good at receiving data. Okay, not bad. Let's try this again. Let's send something from the simulator. This is a fairly small image, so that should populate relatively quickly onto both other devices. We can see in the background here, data is being downloaded, and the image has indeed populated across. Let's try it one other way from the iPod. This is the sushi team on Miami Beach. This was given to me by a very nice man from the Parallels team, Sergey. And he's given me that as a present from Russia. A lot of data traffic I can see here in the background. You can probably see this better if you connect your own devices, and you can see the data traffic going back and forth in iCloud. And there we go, image has populated, just not onto the simulator. So it's the same as what happened yesterday. Okay, that was iCloud document storage. Next up, we're going to have a look at how to integrate iCloud with core data.